Hi, I'm Derek Robinson. I'm a senior online course developer here at InterSystems, and I'm joined by Elijah Cotterill, one of our sales engineers. Elijah, how's it going?
Oh, I'm doing very well, Derek. Thanks for having me.
Yeah, of course. So in some of these prior videos, you might have seen that Elijah's walked us through some concepts with generative AI and setting up your environments and looking at RAG architectures. So you did show us some of the basics of setting up a development environment in those prior videos, but looking a little bit closer at LangChain in particular was one of the technologies that you walked us through. Are there any more components or libraries that are useful and beneficial for developers that they should know beyond the basics of what you already covered?
Yeah, that's a great question, and the answer is yes. So LangChain as a framework is a great place to start, and especially if you want to explore different ways to retrieve data for RAG, or if you want to look at different ways to design your prompts or different ways to build agents effectively to interface with your language models. So often you can find that LangChain will have several packages built in. There are also community packages, for example, for certain integrations to maybe vector databases or any other services really. And there are also some experimental features as well that we might touch on a little bit. But I'd say that depending on your use case, fundamentally you can bring in pretty much any Python library that you are already familiar with. And part of the benefit of using Python is that it has so many libraries. The community around it has created such a sort of vast ecosystem that for pretty much any problem, there are going to be, 10 good ways to approach that with some already, well-built libraries to integrate with.
Yeah.
But yes, absolutely. We'll sort of explore a couple of them here, particularly looking at a couple of ways that you might apply web searches to your RAG applications, and a couple of ways that you might want to try and optimize aspects of particularly the prompts that you're submitting to a language model, and how you might sort of validate the accuracy of those.
Right. Nice. So you mentioned there the prompting. So it kind of seems twofold. Like there's the components and the libraries and things that you can add, and then there's also what you do to be able to structure what you're giving to these models, right? So can you talk a little bit about some of that and those differences in the prompting techniques that you might use with these components?
Yeah, absolutely. So it's there's a really interesting sort of area of research going on at the moment, where some of the results have found that actually applying a particular sort of series of techniques in your prompts can actually improve the accuracy against a more general language model, more accurately than having a very finely tuned one. So I'll actually show an example over here. These are some, you can actually find these resources on one of Microsoft's repositories. They've got a whole bunch of resources around this. But in this particular sort of research, they were looking at how well you can diagnose certain sort of patient conditions. And what they're doing is they're using actually the same language model, but with different prompting techniques, they can increase the accuracy significantly from below 80% to just over 90%. And we'll look at a couple of these techniques, but particularly using a few shot is something that a lot of people are familiar with. This is where you pass examples of correctly answered questions directly to the language model, so it can do some in-context learning, and it can use these examples to craft its own response. And then we've also got chain of thought, which we're going to look at a bit, which is effectively like telling a language model to explain your working. Right. Why does this make sense? And again, that increases the accuracy substantially.
Right.
And again, there's a lot of research around this. So chain of thought in particular, this diagram on the right-hand side you can find in this actual publication, but and bear in mind this was from 2022, so it's evolved a lot since then. Right. This is using GPT-3, right? But again, what they found, this was based off of how well a language model can solve sort of worded mathematics problems, right? So these might be sort of grade school level. If Bob has 8 apples and he drops a couple, that sort of thing.
Yep.
And what they found was these blue lines here show when they applied chain of thought prompting versus the black lines where they applied standard prompting. And you can see that actually the accuracy jumps significantly for quite a few of these models.
Yep.
And we're not going to spend too much time talking about this, but a lot of these techniques have evolved quite a bit. So from chain of thought, you can then say, well, why not show multiple ways of solving a problem and let the language model effectively come to a consensus. So this is almost like having, 3 or 4 experts, discussing amongst themselves to get to an answer, and even that improves accuracy sometimes. So we'll cover a few of these.
Right. Nice. Yeah, that's great. I think some of those concepts, that people may have learned in other materials being put into context there a little bit. So kind of bringing it back to the RAG architecture that we, in one of the previous videos, you walked through an application and sort of exploring how that all works. We talk about embeddings as a critical element within this structure to be able to make generative AI really work. Can you tell us a little more about embedding models and how developers might choose which one to use and kind of the relevance of picking that component in their architecture?
Yes, that's a really interesting question, and I think that there are a few things to consider. That there are actually rankings for some of these embedding models, which you can. There's a very popular ranking on Hugging Face, which we can link. But there are a few things you want to consider. Firstly, the dimensions of the embeddings, right? So you can have anything from maybe about 300 or so dimensions to your vectors to having upwards of 10,000.
Yeah.
So, this does have an effect on a few things. So firstly, the accuracy with which you can then find similarity. So having more dimensions typically means that you can actually have a slightly more finely grained way to cluster these vectors. But also it will affect performance. So if you're running similarity searches with a cosine or a vector dot product, a larger vector will take significantly longer to actually compute these things because you have to effectively combine each value against each other. So a few things to consider. I'd always say first try and check the rankings. See how they actually rank, because more dimensions doesn't necessarily mean better at all. But yeah, some of them are more finely tuned for certain use cases as well.
Nice, that makes sense. So kind of as we step back, and I think a lot of the audience, when we think about this RAG architecture, and we have oftentimes glossed over the LLM piece of it, and a lot of people in their mind probably are thinking about ChatGPT or Gemini or some common public model. If we want, maybe take a minute for developers that might be wondering about locally hosted LLMs and what the kind of situation is if you might use one of those instead of a common public one, and kind of what should be considered there.
Yeah, that's a really great point. And I think that there are sort of open models, like Olama, for example. And again, we have a resource sort of pointing to a whole list of ones that you can use. What I'd say is that actually, performance does seem to be improving a lot on a lot of these models. So, initially when you try to run one of these, you might get 0.7 tokens generated per second or something. It just isn't great. But performance is improving, but you may need pretty good hardware to run it. But in terms of just experimenting directly with a language model without any barriers, I think it's a great opportunity to do that. You'll need to be wary of being able to sort of set up inference with these models as well. The hosted platforms typically have their own APIs set up. You'll need to work on that a little bit to make sure you can integrate it properly. But that there are sort of open source integrations out there for some of the more popular open models.
Right, gotcha. Nice. So kind of bringing it back to what the developer needs to care about for setting up their architecture. What are some of the ways that we can really help to compartmentalize and isolate the pieces of these architectures so that it's not such a monolith where they have to rebuild everything every time they make an update, or have it just how to make it a little bit more targeted in it's the way it's pieced together?
Yeah, so there are a few sort of interesting ways to do that. And, part of the reason LangChain is called LangChain is because it's based on this idea of effectively chaining events. And one of the ways you can sort of do that effectively is using something called agents. And I've actually got a quick demo here, so I'll just give a couple of examples of how we might use an agent. So we'll be using one of OpenAI's models, just GPT 3.5. And we'll define a couple of methods of searching here. So what I'm actually doing is I'm going to use the retrieval method for searching on DuckDuckGo. And again, this is built into the LangChain library, so their integration is already there. And what I can do is I can initialize an agent, and I can effectively give it access to a certain toolset. So what I'm doing here is I'm giving it access to my search object, which is using DuckDuckGo. But this is a list, so I could add something else here as well. If I had a certain vector database, for example, we could add that as well. And again, you assign a particular language model to the agent. And what you can also do is define sort of a prompting technique. So here we're saying zero shot. So zero shot is when you don't actually provide any examples, you effectively just pass the question directly. Yep. So if I then pass to my agent, what is the capital of France? What it'll do is it will start the chain, and it's sort of got this internal monologue here. I should search for the capital of France to find the answer. Action, and then what it's doing is it's choosing this DuckDuckGo search. That's the only option it has, but if it had multiple, it could make that choice. Capital of France is what it has decided as the search prompt, effectively, for DuckDuckGo. And then it finally returns capital of France is Paris. Right, so this is just a super simple example of an agent you can set up using a search engine. And then, something else you can do over here, I'll just actually set up this database quickly. And what we can do is we can set up a zero-shot agent against the database as well. So it's very sort of similar method. We've got this create SQL agent method built into LangChain directly. So LangChain has a whole sort of framework for building agents if you want, and again, you can build them from scratch as well. It's not too difficult in terms of abstractions. But we can just specify the language model. You can specify the toolkit, which in this case is the SQL database toolkit that comes with LangChain. So this is how you would interface with SQL database. And this means that what it can do is actually apply text to SQL directly. So this means when I pass it my prompt, I don't need to pass it a select statement. I just say, tell me the capital of France, tell me something. And it can then create a SQL query directly based on the database. So, and we can also specify zero shot. I'll just create this method quickly just so we can count the number of tokens being used. But now, if I run this, what we're doing is we're using our agent executor, which we defined up there. And I'm saying, what is the multiplication of the ratio between stock prices for a couple of different things on this particular date? And what it does is, firstly, it turns this into sort of a natural language input, which it can then pass to a language model directly. That's why we specified the LLM when we specified the agent. What it does is it uses the LLM to then create a query directly. So what it's done here is it's created the table, stored it somewhere, and now we can retrieve those directly using text to SQL.
Yep. Right.
So that's just an example of a couple of different agents that you might have. But again, as I said, you can define agents with multiple retrieval methods. You can define agents with different language models. So you can get really sort of quite creative with this and chaining them together as well.
Yeah, right. Nice. That really seems to help with that sort of freedom of being able to use different pieces of the architecture for what they're best at, right? So when you talk about those retrievals, a lot of what we've talked about so far and in the previous videos that you walked through is a relatively simple retrieval case where we're taking a vector database or some kind of vector storage, and it was InterSystems Iris in our case, and running some similarity searches on vectors that are stored there. What are some maybe more interesting retrieval methods that you might see in a RAG application? And if you have anything to show that might be a little bit more complex or kind of interesting as an example than just pulling from vector storage.
Yeah, so that's a great point. And what I would say is, you can use effectively whatever retrieval method you want. That could be anything from, as we just saw, you can query a database, you can submit something to a search engine, you can pull documents directly from the cloud. You can build an integration to pretty much whatever you want. That's the nice thing about RAG. You're not sort of tied into any particular data source. Yeah. I think what I'd say, though, is the future is probably going to be around combining these data sources in an interesting way. So you may find that you first query a vector database, and then you retrieve some URLs directly from there. You then do a search on those URLs. You then take certain results from those, pass them somewhere else, and cross-reference them with a different data source. And language models can really just tie together a lot of these pieces, particularly when you have sort of qualitative data. Right. So you may have a lot of sort of long reports stored somewhere. And being able to sort of embed these or just being able to analyze them with a language model is going to be vital, really.
Right. Yeah, that makes a lot of sense. So kind of tying it together and concluding here, the last question I have for you is really maybe forward-looking to developers who might be ready to get started. This is probably not nearly enough time to cover all the things that you'd want to cover with this question, but what are some of the biggest tips or things that you'd recommend to consider when it comes to optimizing all of this to actually move forward into production with applications like these?
Yes, that's a really interesting area of research really.
Yeah.
How do you effectively, how do you create efficient prompts without having to just manually write, layer after layer of, please don't reject this particular term. Please go into detail about this, right? There's an incredibly tedious process. And the fact is, if you've got skilled software engineers, you don't want them to spend all of their time trying to cover edge cases with, manually written natural language prompts. So there are some really interesting libraries out there. I think the first one that comes to mind, because it seems to be far ahead of most of the others, is DSP, or DSP, which is sort of a research project focused around being able to optimize your prompts directly. So they effectively what they do is they allow you to define a validation metric. And, the simplest validation metric you might have is, let's say I've got my training data or my test data over here, which is a bunch of questions and answers that I've already got. The simplest validation is, does the answer from the language model match the answer in the test data? If it does match, give it a 1. If it doesn't, give it a 0, right? That's the most basic validation you can do. But of course, you can then define more appropriate validations using language models. And what this allows you to do is effectively be able to automate the process of refining your prompts by, almost compiling against this validation metric, where it will consider different cases. It will consider your test data to then try and refine the prompt that it's submitting. So I'd say, for any developer that's really serious about trying to make this work, for a variety of cases or being able to sort of automate a lot of that, I'd say, check out DSP. And I think, more generally, check out a lot of the work that's going on, particularly from these university research groups. Yep. So DSP comes directly from the Stanford NLP group.
Yeah.
They've got a lot of interesting stuff going on, and that's really where this is happening.
Right.
And I think just more generally, I'd say, a lot of the research that's coming out is very fresh, and it's also quite approachable. So don't hesitate to sort of, start reading the actual archive documents. Don't hesitate to really, try and take a deep dive into what these researchers are doing, because a lot of it is brand new. And, as we saw from that first diagram, the difference between what they were doing in early 2022 versus what's happening now, it's jumped hugely.
Right.
So yeah, there's a lot to explore.
Right. Gotcha. Yeah, absolutely. So, well, Elijah, I think you've given developers plenty to sink their teeth into. So I'm sure hopefully this launches a lot of people to go explore some of those and gave them the tool set that they need to be able to explore some of these components and libraries that are available. So thanks for joining us.
Oh, thank you.